Hello everyone, this is my presentation on an immunosuppressant drug that is used to help prevent rejection in kidney transplants. The one that I picked is tacromulus. It's also known as Prograf. It can be used in combination with other medications. You kind of have to take a bunch of different medications in order for them to all act well together to prevent rejection of organs once they've been transplanted. And for kidneys, tacromulus is one of the ones that's used for that. You can use it with steroids like prednisone, azathioprine, and a couple other medications. It's kind of like a drug cocktail in order to make sure that the organ is taking and that the body is not trying to reject it and attack it. It's an immunosuppressant, and it works to decrease the activity of the immune system to prevent it from attacking the organ that was transplanted. And like I said, in this case, it's a kidney. It can also be used in other transplant cases like liver and lungs, but it's more specifically for kidneys. There are a bunch of side effects that can occur with tacromulus. Some of them are not as severe as others, but if they do become in the more if they start to occur in this second section here, that's when you have to pay attention to them because they can lead to death if they're not treated. But just some of the main side effects are headache, diarrhea, constipation, nausea, vomiting, loss of appetite. It can cause insomnia too. Can cause pain in the joints, or you can get a burning, numbness, or a tingling sensation in the hands or feet. Once you get into the more severe side effects, it can actually cause issues within the body, and this can actually cause harm to the kidney that has been transplanted as well, because it starts to attack the body and kind of creates confusion within the body, so it starts to attack the organ that has been transplanted. This can be limb swelling, can cause seizures or vision changes, and if you get into those side effects, you need to contact your doctor to make sure that they can change the dosage or start you on a different medication. The mechanism of action for tacromulus is that it reduces peptidyl-prolyl isomerase activity, and it does this by binding to the immunophilin FKBP12 to create a new complex. This complex then inhibits the T lymphocyte transduction and IL-2 transcription. So lymphocytes are the immune response, and they are used in order to prevent infection within the body. But if they see that there's a foreign object, like a transplanted organ, they can overreact to that and start attacking it as well. So that's why we have to use tacromulus in order to inhibit this so that it does not attack the kidney that has been transplanted. The complex is made of tacromulus FKBP12, calcium, calmodulin, and calcineurin, which is informed, and the phosphatase activity of calcineurin is inhibited as well. And then this prevents the dephosphorylation and translocation of nuclear factor activated T cells. The nuclear component that it's inhibiting is also thought to initiate gene transcription for the formation of lymphokines. And tacromulus also inhibits the transcription of genes that encode for IL-3, IL-4, IL-5, GM, CSF, and TNF, and these are all involved in the early stages of T cell activation. And again, if those T cells do become activated, that's when they enact kind of an immune response and want to go and attack the foreign cells that they think are in the body and remove them. Tacromulus has also been shown to inhibit the release of preformed mediators from skin mast cells and basophils. It can also downregulate the expression of FCERI, which is just a high affinity IgE receptor on Langerhans cells. And tacromulus has similar activity to cyclosporin, which is another immunosuppressant drug, but tacromulus has lower rates of rejection, so it is a bit stronger, and that's why it does have more severe side effects. But it just has to be monitored just to make sure that these aren't affecting the body. This is the molecular structure of the immunosuppressant. It is a pretty big molecule, as you can see here. And then this is just a diagram that shows how tacromulus works within the body. So you can kind of see here is the T cell down here. So we want to make sure that these are inactivated so that they are not attacking the organ that has been transplanted. and you can see the receptors that are holding in for that. And then these are the references that I used in order to get this information. I hope you enjoyed it. Thank you.